Okay, so now let's move on to question number 4. So as you can see in the question number 4, you're given the number of sightings of golden eagle at a certain location to have a Poisson distribution with mean of 2.5 per week. Drilling for oil is started nearby. A naturalist wishes to test at the 5% significance level whether there are fewer sightings since the drilling began, full stop. He notes that during the following 3 weeks there are 2 sightings. So again, this is a hypothesis testing, right? So you have to keep that in your mind, and we're also given a Poisson distribution. So the first question simply asks us to find the critical region for the test and carry out the test. Second question is just state the probability of type 1 error. And then third question says state why the naturalist could not have made type 2 error. So in this question, let x be the number of golden egg sightings. And if we write it in a proper notation, here x is such that it follows a Poisson distribution with mean of 2.5. Now, if lambda is 2.5 per week, then in 3 weeks, lambda is just 7.5, right? You just multiply it by 3. So when you multiply it by 3, it's new lambda per 3 weeks. Okay, so it's per 3 weeks. Now, if we assume x1 to be a new variable here with the new mean 7.5, then at 5% significance level, we have to test a hypothesis that H0, that is the null hypothesis, remains the same. That's 7.5. And the alternative hypothesis is less than 7.5. We're testing that we have less sightings in 3 weeks. So then, if we find a probability of x less than 2, okay, you find your answer to be 0.0203. Okay, in this case what you do is px equals to 0 plus px equals to 1. When you add those two probabilities, you get this. Okay, now because your probability of sighting less than 2 gives you 2% significance level, and because it's less than 5% significance level, we say that and of course if it's less than 5% significance level, it's in the rejection region, right? So then we can say that we reject the null hypothesis that the number of bird sighting has not changed. Hence there is evidence at 5% significance level that the golden eagle sighting has decreased. If your probability, in this case the probability, falls below the 5% significance level, right? So in that case, we say that it's in the rejection region. If you had a probability that was more than 5% or more than 0.05, then you say that it's in the acceptance region. And then you accept the null hypothesis. But because in this case 0.02 is less than 0.05, we say that it's in the rejection region. So next question is basically asking us to find the probability of type 1 error, right? So if you want to find the type 1 error, you only have to understand the significance level that it represents, right? So in this case, the type 1 error is 0.023203. And in the third question, we are asked why naturalists could not have made a type 2 error here. Now there are two different reasons for this one here that we can think of. Okay, and before that, what we will do is we'll understand what is a type 2 error here. So probability of type 2 error, it simply means probability of accepting a null hypothesis given a changed mean. Suppose your mean has changed, and still then what's the probability of finding the null hypothesis? What's the probability of accepting the null hypothesis is a measure of type 2 error here. Okay, now let's read this out. As we do not know if the mean has changed, so we cannot find type 2 error. In this case, we have not been given a mean, the changed mean here. So we cannot find a type 2 error. There's no meaning to finding a type 2 error. And also, as the null hypothesis is rejected, we could not have made a type 2 error here. Right? The null hypothesis has already been rejected. But our question here was the probability of type 2 error means accepting a null hypothesis. So the hypothesis has already been rejected, so we could not have made a type 2 error. Even if we had the mean changed. Okay? It wouldn't have made sense. Okay, so now let's move on to question number 5.